So now we're going to do 9.2.5t. Got to change sections here to 9.2. 9.2.5t. There it is. Means from independent samples. First thing I see is there's no sigmas. Everything's S, so it's all sample data. So we're going to use t-test. And where's the claim? Okay, part A. Test the claim that the contents of cans of diet soda, which is sample 1, have weights with a mean that is less than the mean of regular soda, sample 2. So that would be mu1 is less than mu2, which is C, letter C. That's the alternative. Remember that the null hypothesis is always equals, always comes up that way. So for the t statistic, I have summary data, so I go to StatCrunch. I go to stat t-test, 2 samples with summary. I just got to enter all this in. It's sitting right there. So for number 1, the sample mean is, and I'm not going to round anything off, 78489. Standard deviation 0.00441. And sample size is 29. For number 2, sample mean 81,811, so 0.81811. Deviation 00756. And sample size is 29. And we said it was a left-tailed test, that mu1 was less, so I have to change this to less than. mu1 is less than mu2. That's algebraically equivalent. So compute, and the t-test statistic is minus 20.44. Looks like it's going to be significant. We're way to the left. Minus 20.44. We're way in the left tail. I didn't see the p-value. I didn't really look. The p-value is 0. Oh yeah, it's 0. That means we're going to reject the null hypothesis. So reject the null. There is sufficient evidence to support the claim because the claim is in the alternative hypothesis. That's what we're supporting because we can't support the null. So now we got to go back. We open up, we want the confidence interval. We go back, hit options, edit. Just change from a hypothesis to confidence interval. And the confidence interval for this one, it's a 0.5, once again, it's a 90. You got to do 90 because it's a one-tailed test. So if 5% goes in the left tail, then you got to balance it with 5% in the right tail. And so we compute. And 3 decimal places, it'll be 0.36 or minus 0.36 and minus 0.30. So minus 0.036 minus 0.030. Once again, it's all negatives. No 0 in the values. 0 is not in that interval. Does the confidence interval support the conclusion? Yes, because the confidence interval contains only negative values. There's no chance for them to be equal, which would be the null hypothesis. That's it. That's problem number 9.2.5. T. Dr. K. Over and